All right, guys. Welcome to Python tutorials. We're taking Python tutorials. In the last video, we looked at Python, the while loops in Python. We're still looking at looping constructs. And in the last video, we looked at the while loop. The while loop is good for loops where you can't actually know how many iterations are going to happen. That you can know the number of iterations during while you're still developing the code, or at the time of development, you can know the number of iterations that are going to occur in the loop. That depends on the user or the use case of that particular program. But in the for loop, a for loop is good when you know, and in that case, we call that an indefinite loop, a loop in which the number of iterations cannot be known ahead of time. It's known as an indefinite loop. You can have one iteration, you can have zero iteration, you can have two iterations, you can have three iterations. You aren't actually sure the number of iterations before the program is run. So only at runtime you can only know the number of iterations at runtime, or sometimes you can't even know the number of iterations at runtime. We call that an indefinite loop. While a loop in which you can know the number of iterations, for example, if you have an array with items, say 10 items, if you want to write a loop which will iterate through that array or that list or that tuple, you'll be sure you have 10 iterations, except you're using a break statement within. For such kinds of loops, you want to use a for statement, because a for statement was designed for these kinds of definite loops. That's loops in which you can know the number of iterations. So we're going to be looking at let's dive directly into the video so we can look at some examples. I'm going to show you first an example of a while loop, while I call it an indefinite loop, and I'm going to show you how you can use a for loop for a definite loop. So let's dive directly into the video and get coding. All right, so here is a program that takes a number from the user and adds it to an accumulator. As you can see, we have a variable accum assigned to 0. We have a variable you input initialized to 0. Sorry, we have number of iterations initialized to 0, and we have a while loop. Now here is a while loop which we learned in the last video. The while loop actually takes we iterate over while u input greater than 0. Here's the conditional expression. We're testing u input. As you can see, initially user input is equal to 0. We initialize user input to 0. So we have a while loop. It checks while the user input is greater than or equals to 0. It takes some input from the user and stores in that user input. Now, whatever the user enters is a string on the keyboard, so we convert it to an integer and then we add it to the accumulator. Now we increase the number of iterations, increment the number of iterations by 1, and then we print out at the end of the loop. That's when u input is less than 0. That's the user enter any negative number. The iteration, the while loop will be terminated, because u input greater than 0 will be equivalent to false. If you don't understand the while loop, you can look at the last video where I explained that in details. And if you're not familiar with Boolean expression like this, u input greater than or equals to 0, you can also check the video where we dealt with different kinds of expressions like Boolean expressions and logical expressions, Boolean expressions, and all the rest. We have done that in past videos. So in this video, I'm assuming you're already familiar with a lot of with most of these things. So let's try to run this program and see how it behaves. So as you can see, we have enter, and we have 7. I'll just enter some random numbers, and I'll enter -1. Now you see we have the accumulator is 36. If you add all these numbers together, you get 36, and you can see the number of iteration is 7. So for this program, for this execution, for this program, that's for this execution instance, you can see we have 7 iterations. Now let's try to run the program again. Let's see. You can see we have 3 iterations. Let's run the program again. And here we have accum -1. Oh, I added to accum. All right, as you can see here, we have 1 iteration. Let's see. Yeah, we have 1 iteration. We enter the loop just 1 time. All right, but there's a little glitch here. We had to correct the program, so we can't take a negative number. So initially we had to, like, let's see, we had to maybe if it was a negative number we had to prepare. Let's not worry about that. I'm just trying to show the number of iterations. So you can see we have different number of iterations. For this type of loop, we need to use a while loop. For this type of condition where we can't detect the number of iterations the program is going to have, or the loop is going to have, we can use a while statement. But for example, let's say we want to display the square root of numbers from 1 to 10. In that case, we know we are going to have 10 iterations, so we are going to use a for loop. Let's see how we can use the while loop to write such a program. Sorry, let's see how we can use the for loop or let's say the while loop to run such a program first. Then from there we are going to show I'm going to show you how you can use the for loop to run such a program. So here is a simple program that finds the square root of numbers from 1 right up to 10. As you can see, we have a variable start, we have a variable stop, which is the ending number. The start is the starting number, and we use a while loop to check whilst as long as start is less than or equals to stop. We print the square root of start. So as you can see, let's run the program so you see the output. All right, 1 squared is 1, 2 squared is 4, right up to 10 squared, which is 100. All right, now take note, to prevent an infinite loop, you have to increment the value of start by um, by 1, as you can see on line 6. So yeah, we can know the number of iterations. Of course, you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Normally, in this we have 10 iterations. Of course, we know we are going to find the square root of 10 numbers. Now, in this case, we can easily use the for loop because it's not an infinite. It's not every time when the program runs, we know the number of iterations. And it's still an, even if we take the stop from the user, for example, even if we take the stop from a user, if we take the stop from a user, for example, we say enter stop value. Even if you take the stuff from a user, it's still just want to show you it's still going to be and it's still going to be a definite loop because we'll still be able to know the number of iterations before the loop runs. For example, in this case, we know stop will always have the number of iterations. So let's say we are taking the number the stop value from the user. You see, as we write this, you see now the user can enter 22. We'll find it up to 22, and the user can enter 14. This is still a definite loop because we still are able to know before the loop is executed, we are able to know the number of iterations. Of course, we know the number of iterations is stored in the value stop, unlike the previous program where we can't know the number of iterations before the loop because it depends on the value entered by the user, and we can't know what the user is going to enter as a value before the loop body. So here we can say okay, stop. Now for this we can simply use a for loop to write this because we know this is an indefinite loop. For that, we're just going to use the range function. We're just going to say for var in range. Of course, if you haven't watched the video on the range function, you can watch it. We create a range from let's say 1 right up to stop plus 1. So we move one time at one value ahead of stop. We can now just say var is let's say var. So in this case, we don't need we can just take only the stop. We don't need the start because we already know the start. So if we run this program now, of course we can say 15. Oh, sorry. Oh, we have a problem here. We have name start is not defined. Sorry. We don't even need this line of code here. Sorry. All right. So let's take 15. 15. All right. So as you can see, this is an example of a definite loop where we are using the for statement to get the different values within a range object. So like we saw in the range object, we saw in the video on ranges, a range creates a list or a sequence of values from start right up to stop. That's the range function creates a sequence of values from start right up to stop. So in this case, we are creating a sequence of value from 1 to stop plus 1, and case stop is any value entered by the user. In this case, I entered 15, so stop is going to be 16. Of course, because we know the range creates a range of values from 1 right up to one value less than the stop value, because the stop value is not included within the value generated by the range. So if you want values from 1 to 15, you need to put 16 as the second or stop value. So let's see how the for statement works internally. Now the for statement can be used to iterate over a sequence of items. You know, we can have a list and we can want to use the for statement to iterate over a list. For example, let's say you have the list all right, let's say you have this list with this number of items and you want to iterate over this list. For example, let's say you want to find the square of all the items within this list. You can use a for statement for, let's say, a var for, let's say, for v in my m list Now you can now print the square of that value. You can say v times to the raised to the power 2. So this is it. So as you can see, now let's the way the for statement works is that v takes values sequentially. The first time in the first iteration, v is the value 1. The second iteration, v is the value 3. The third iteration, v is the value 4. For example, if we print just v, you're going to see how this statement works. If we print just v, you see we have 1, 3, 6, 7, 8, 9, 8, 10, 12. So v continuously take different values until the end of the loop. The for statement is able to detect the end of the loop, so we don't need to worry to tell the for statement where the loop ends. It's able to iterate through the loop. And the for statement can also have an else portion. In this case, let's say else, uh, um, let's say print done. All right, we call this the for else statement. As you can see now, you see loop done. Now when is the else statement executed? Once the for statement reaches the end of its sequence or loops. Remember, this can be a tuple, it mustn't be a list, it can be a tuple, any iterable. It can work for any iterable, so it mustn't be a list. It can also even be a set, so you mustn't use just to make you know, it can be any of this stuff. So all right, so it can be a list, it can be a tuple, it can be a set. So, but the for statement actually iterates through each value of that sequence. We call these sequences even a string. You can even be a string like hello, for example. It can be a string like hello, well, for example, and it still works, I think. Yeah, all right. So it can work for any sequence. It can work for strings, lists, tuples, not dictionary because dictionaries. So let's say sets and the rest. So let's use our lists as before. All right. So the first iteration, the v will be 1, and this v can be any value. I can even use my name. It can be any value. Okay. It mustn't be a particular value, but people just like to use var and some, just to make things look a little bit easy. And so it can be any value. So the different items of the list will be assigned to that value per iteration. So the first iteration is going to have value 1, the second iteration 3, the third iteration 6, and so on and so forth. So now once the for statement reaches the end of its sequence, it successfully reaches the end of its sequence, it is going to print go to its else part. So you can use the else part to know if the loop ended successfully or not. Now let's say within the statement we used a break statement. Let's say if v equal to, let's say, 8, break. So at this point, what we're doing is we're going to terminate the loop at the point 8. Now, when a loop is terminated before its end, the else portion of the for statement is not executed. You can use that. I'll show you a program where we can easily make use of that. But in this case, let's just see how this program runs. As you can see, we have 1, 2, 3, 8. So it prints out 8, but this statement becomes true. And all right, so as you can see, once we use the break statement, the else part of the loop is not executed. So you have to understand the difference between you have to know how the else part works. The else part is only executed if the for loop executes completely without having any break statement within. Now, how is this important? Okay, let's write a simple program that in which a user enters a value to search, and we search a list of items to find if that value exists. If the value exists, we are going to tell the user, all right, we have found the value. And once we find the value, of course, we have to break because you can't continue searching. It's more efficient to break out of a loop once you find, if you're writing a search algorithm, it's more efficient to break out of a loop once you find the value or the search item or the search query. Or once the query is found, you have to break out from the loop because, for example, if there are a million items in a loop and you find the query or the query string in the second or third item, the second or third position of the array, you wouldn't want to check all the 1 million items because you've already found the value search for. So you have to break out of the loop And so you always need to use a break statement or even a continuous statement. Both the break and the continuous statement is being used, but particularly with a continuous statement, the loop is always going to reach the end. Like I'm going to show you that too. But with the break statement, the loop is not going to reach the end. So the else part of the loop will not be executed because the loop did not reach the end. So at this point, let's write the program to for where the search program I'm talking about. So you see how the else statement can be put into use. All right, so here's the program we have written. Actually searches a list of items, a list of numbers, integer values for an integer value input by the user, so provided by the user. So here we can see we collect an integer value from the user and assign to the identifier u input. Remember, we can't use the a name input as a valid identifier, but we can't use it or else it's going to replace the inbuilt function input, and you're not going to be able to collect any input from the user again, because if you do this, you're going to collect an input from the user and you're going to replace the input function. So since input is a built-in function, we will not want to use an identifier called input. So that's why I always use u input. So don't make that mistake to use the input or even the len function and so on as an identifier, because you're going to replace the actual built-in function declared by Python. So we assign the identifier to the whatever integer is entered by the user, and now we have our for statement. We iterate through the loop, this loop list, and for each iteration, of course, like I told you, v will take successful values from start right up to end. For each iteration, for successive iterations, v will be taking the next value for right up to 151, 36, and so on. Okay, now if we find the item, you see we break out of the loop and we tell the user the item was found at a particular index. If not, that's if the loop reaches the end without us finding the item, of course, we can peacefully print out the value was not found, because if the loop successfully reaches the end, it means we did not find the value, because if we found the value, line 7 will be executed, because this statement will become true, the v equals to u input will become true, and we are going to line 6 and line 7 will be executed, and of course line 7 breaks out of the loop. So like I said, when you break out of the loop, the first statement will not be executed. So in that case, we're not going to have this statement printed out. So as you can see, for example, if we have this and we search 150, you can see 150 was found at the last position index 10, and the next one, if we search, let's say 12, you can see 12 was found at position 6. We're going to learn the different string methods, but the list methods later on. But as you can see, the index function of the list of a list object actually returns the index, the first index of a particular value. So for example, if we say list list is our list dot index of, you can check it out. Let me show you guys. So let's say we have a list here, L equals to 1, 2, 3, 4, 5. So we will say L dot index 1. You see, gives us 0. So you see 1 is at the first position, which is 0. What of L dot index 4? So give us 3. So that's what I'm actually using here. So we said item the item probably with this, so this u input to replace this placeholder, and this list dot index of u input to replace this other placeholder. So we're going to see all that later. Those are string methods, and this is the string format method, so we're going to look at that. But yeah, I just want to show you how we can use the for loop to iterate over a list of items. And remember, this list of items can be written directly here. It must not be there. You can write it directly here. Yeah, so let's comment out this. So we can write the list of items here directly, okay, directly. And let me show you guys. So let's see if we use the list list the index of, no, in this case we can't even find the index directly here. We can just say, let's see, in this case we can't have a reference to the list, so this we can't. Let's just say was found at index. We need to create our own index. Let's say index equals to 0. Yes, so then after every iteration, we're going to increment index plus equals to 1. So we're creating our own index, because this we don't have a reference to any list, because we generated the list in place statically we generated a list in place, so there's no name or variable attached to this list. It's just in memory, so we can't reference it. So we need to create our own index, so we can automatically write index here. Don't need to worry if you don't understand all this. I'm just trying to straighten out things here. So I think this index here should be correct now. All right, so let's try to run it. We may have an error or not, I don't know. Okay, so let's try to find 150. All right, index 10 still the same, and let's try to find 1 and the 0. All right, so we can see that's how it works. So let's look at, as you can see, since the else, but let's say we search the value which is not found, you're going to see the else part will be executed. Let's say this value is not there, so the else part was executed because the for loop reached right at the end and it had to execute this else portion, and we know once it reaches at the end, it means the value wasn't found in our case. So let's look at more examples using the for loop. Take note, it's possible we can also have, like I explained to you, this can be a tuple. This can be a tuple. Let's see. Yeah, this can be a tuple, and you can also use the range function, like I told you, to generate a range here. Remember, you can use this. Remember, a range is also, the range object is an iterable. Like I told you, if you use range, a list is not returned in the range function. For example, let's say r equals to range 10, or let's say 11. You see, if you press r, you see it's a range object, it's not a list. It's a range object, it's not a list. You write type r r. You see, it's a class range, but usually the range object is usually converted to a list. Usually, this is what people do. We usually use the list function to convert it to a list, or we can use the tuple function to convert it to a tuple. So if you write r now, a list is going to be printed out because we converted it to a list. So as you can see, type r also gives us the list, and possibly you can also, it's not only a list, you can also convert it to a tuple if you want. For example, here is a conversion to a tuple, so you can see r is a tuple, and if you write type r, you're gonna see you're gonna have a tuple. You can also use a set. You mustn't use a tuple. You can use a set to convert the range output to, you can see. So while using a set, you can see if you print r, you can see it's a set, and if you write type, for example, r, you can see it's a class set. So usually you have to convert the range object to what you want. But the good thing about the for loop is that you don't need to convert the range object to a list, a tuple, because a range object itself is a sequence. When we are going to look at generators, you're going to see how you can, later on you're going to see how you can create your own sequence for your own use. But I just want to know how the range object is a sequence. So for example, if you create 1 to 11, of course, if we can create a range on the fly, and it creates, let's say if you do this, if you print let's say list, let's see what range 1 to 11 creates. 11, you can see it creates a range of 0 to 10. So for it, we know here we're going to have an output of 0 to this is going to give us 0 to 10. So we just try to copy it for convenience sake, but like I'm telling you, you have to understand it's 0 to 10. So I'm going to put that here. Okay, so here is what we're going to have just for convenience sake. So 0 is in the list and all this. So if a user searches a value, for example, if a user searches 5, we can be sure 5 was found at index 5. But if the user searches the value 11, we can be sure 11 will not be there. But if we added maybe 15 here, we can say we have up to 14. Yeah, 14 is at index 14, and 15 is at index 15 is not found. Remember the range function, we is from the start right up to a certain end number, and the number is not part. Remember, we can also have step values. For example, in this case, I think you understand how the range function works. If you use step values, for example, if we start from 0, by default normally it's 0, and you have 2 as a step value. Here you have an output. So you can use whatever you want, but I just want you to understand the range function. The for loop can iterate over the range object, because the range object is an iterable, and the for loop can iterate over any iterable. That's simply, I think that's simple to understand. So let's look at some other ways in which let's look at the longer example in the different ways in which you can use the for statement. Now, before we continue, let me show you how the first statement makes life easy. For example, let's say we want to count from 1 to 15 with a while loop. Okay, initially we are going to have a start value and end value, or let's just say a start value, and we're going to have starts or equals to 0, and we have to say while start less than or equal to 15, you're going to print. Let's say we want to find the square root of the value. You're going to print start square, for example, start square. We must increment start by 1 so that we should not have an infinite loop. All right, so let's do this. Now, as you see, to print the square root, we need three parts. We have an initialization part, we have the test value, and we have an incrementation part. But with the for loop, you can simplify this by you don't need all this. You just need only the first statement. For example, you just say for var in range, you just put 16. So I want to show you how it's much easier to use because it's a definite loop. The for was designed for definite loop, so it makes iterating through a definite range of items very simple. So this is all you need. You just see, and you can even, since it's just one, you can even simplify it in one line. So as you can see, what we did in three lines can just be done in a single line with this statement. So here is the same output, okay, and there we go. So the for loop makes life very easy for us, and it's simpler to use the for loop for a definite loop than using the while loop. So let's look at some other more examples for which you can use the for loop or the for statement. All right, so here is a simple program where I'm showing the different scenarios in which you can use the for loop to iterate over a text, to iterate over a list, to iterate over a tuple, to iterate over a set. So here we have a text assigned to a string. Let's say text, an identifier called text assigned to a string object. Here we have an identifier list1 assigned to a list object, and we have an identifier list tuple1 assigned to a tuple object, and we have an identifier set1 assigned to a set object. So in this case, you see we can iterate over a a string. In this case, the car, that's the car, this value will have successful characters for each iteration. So we're going to have WEL right up to this space. Then we have TO up to a space character. Remember that space is also a valid character in programming. So at some point, car will be equal to a space character, or will be assigned to a space character, or have the value of a space character. All right, so let's just run the program so you see the different outputs. So you can see, starting from here, as you can see, for each iteration, we move from W right up to E, as you can see. In the next one, we are iterating over the list item. So item is going to take successfully 1, after 2, after the string 2, after the float value 3.5, after the complex value 4.5J, after the list 6.7, after the tuple this, as you can see. It moves from item has all this, I think about 6 values, as you can see from the output here. Display variable list item, we have 1. The next time item will be 2. The next time item will be 3.5, 4, and so on. Now we use, in this case, we use the value x, and we iterating over a tuple sequence, the sequence which is a tuple. We have 2, 4, 6. So as you can see, x is going to take all these consecutive values based on the different the iteration counts. So we have 2, 4, 6, 8, and yeah. So as you can see here, we can also iterate over a tuple, and as you can see from outside here, and we can also iterate, and at the end, we iterate over a range of values. From the video we did on the range functions, you understand what this is. You know this is actually a range of values from 1 right up to 12 with gaps of 3. So we're going to have, as you can see, we have 1, 4, 7, and 10. So I'm going to run this again. So we have everything. Well, all right. So 1, 4, 7, and 10. And here we can see we're using a positive step of 2, but we're starting from negative 10 right up to negative 1. So we're going to have negative 10, negative 8, negative 6, as you can see here. So neg even is going to be taking those consecutive values returned by the range function. So here we have different scenarios in which you can use the for loop to iterate over any of the common sequences. You can also use it to iterate over complex sequences, which we're going to say later on, like when we talk about generators and the rest. So let's see some more examples on how we can use um, the for loop, so you have a deep understanding of how it works. All right, so before we move on, if you're inquisitive enough, you may be wondering what's going to happen if within the body of the loop you change this value of x, because you know the value of x is assigned by Python and not you, it's assigned by the iterator. The interpreter assigns the value to y, so you don't do it, the value of y changes per iteration. So you may be wondering, what if you assign, like maybe you think okay, maybe you want to print, let's say 1 to 10, let's say for var in range 11, and you may be wondering, okay, what's going to happen if I say if var equal to 5, you come and say, let's for example you set var back to 1, var equal to, you understand, and maybe you want to do it only one time. Maybe you have a boolean here to say set value set equal to false, and you want to make sure you do it only one time. Let's say for example, so you're gonna say and not value and not value and not value set if var equal to 5 and not value set. For example, you want to set it back to 1, and once you do it, you want to say value set equal to true. So you do it only one time. You may think at this point, when you set the value back to 1, it's going to reset and range is going to, like, you're going to have 1 2 3 4 5, and then you're going to have 1 2 3 4 5 6 7 8 9 10 11, because you actually changed the value of var within the loop and you resetted it back to 1, something like that. But that's not what's going to happen. Let's see the output here. Yeah, okay, we end printing. Oh, let's print the value of var. So you see, let's print the value of var. Print var. Okay, so let's see what happens. Okay, as you can see, nothing happened. Okay, even if you don't use the complex, let's say you every time var is 5, you attempt to change it back to 1, so you have an infinite loop. In this case, let's see whether we're going to have an infinite loop. Of course, we have no infinite loop. So just so you know, the value assigned to var within the loop has no impact. It doesn't change the value of var. You can't assign any value to this var here. It's assigned by the interpreter. The interpreter is going to change the value of var from 0, 1, 2 to right up to 10 when the iteration is ended. So you can't take control of this var variable from within the loop. You can only use it. It's only writable. It's only readable. Sorry, it's not writable. You can't assign a value to it, and the compiler is not going to generate an error. It's just going to silently deny your request. So in simplicity, that's how it works. So I just wanted to show you that you can't change this value, the value being used by the loops, so that you understand that fully. To round up this section on for loops, let's look at this last example, where we are going to count the number of vowels in the user's input. So we're going to collect some input from the user, and we're going to count the number of vowels in that input. So it's quite a complex program, because not really complex for those who are good in programming, but it's a little bit technical, because we have a nested if loop just like this one. We have an if loop within a for loop, you understand, but it's not really we have many conditions within it, but we're going to have many conditions within it, but it's not complex. But I just want us to round up with that particular example. All right, so let's look at this example. All right, so here is the code for the program I'm talking about. So in this case, we collect an input from the user, enter some text, and it's a string, so we can save it in a value and use it. We don't convert it to an integer because we expect a string. And we have initialized number of vowels and the identified number of vowels to 0. And we use a for loop for ch in text. So ch is going to assume the different items within our text, the text provided by the user, the different characters within the text, and for each character we are going to check if that character is equals to a, e, or u, and we are using both uppercase and lowercase so that in case there's a mixture of case, we ain't gonna have a problem. So there we go. Now for each time we have a vowel, we increment by one. Each time we find a vowel, we increment number of vowels by one, and at the end we print the number after we print that vowel out in a straight line. So we use the set parameter of the print statement. If you haven't watched our video on the print statement, you can watch it. And we also have the end parameter of the print statement. The set parameter is so that using the comma to separate parameters is going to actually be printed with the separation in character with a like with an empty string. For it, let's just run this example so you understand. Parameters are separated with an with are not let's say are separated with an empty string, or are not separated physically separated. Let me write. So we're gonna show hello world. All right, so as you can see here, we have ch and we have a comma, here, and we have a space. So when we provide a second, when we print out a second param, let's see how this works first, so you understand how this actually works. All right, initially this was going to happen if we write hello world. Okay, you see we have it on separate lines. All right, but we don't want it to be on separate lines, so simply we just have to use end. We are going to tell first of all what we want let's remove now this so you see what happens. So it's a bit difficult to explain that. All right, so as you can see, what happens is when we provide a parameter to let's say when we provide a parameter to the print statement, you see we have two parameters. We have the character and we have a second parameter, or a second argument or a parameter, which is the two strings, a comma separated by a space. But Python naturally adds a space to separate two parameters passed as input to the print statement. So you can see we have the natural space, we have a space between these two characters. Yeah, and we have a space between these two characters because as you can see there are different parameters. We have a character and we also have the comma followed by a space. So this space here is provided by us. This space here is provided by us, but this space here is provided by Python. So to tell Python to not provide that space, we use the separation. Python should not separate. We use separation. By default, separation is an empty space like this. We tell Python to separate it with no. We can even tell Python to separate it with any character we want, but okay, yeah, we can tell. You see Python now uses what, but we don't want Python to, we want Python to separate them with, to not separate the characters, you understand? So we don't want any space between. So you see now there's no space between e and the comma, o and the comma, and also the end character prevents them from being printed. Each print statement is not followed by a new line character. Without the end, each print statement is followed by a new line character like we saw here. So so you see we have a new line character. So that's the use of the end parameter. We tell Python let each print statement end with an empty string. So instead of a new line, by default it's a new line, but we tell Python to use an empty string. So simply that's it. Now this is overkill because you see we have three vowels, and if we say I love programming, I love Python, I love Python Me. So, as you can see, capital letters also work because we both tried uppercase and lowercase. But in simplicity, this is overkill. To be testing many values is like overkill. We can simply create a list or a string of vowels like this. Vowels equals to, you just have a list and you have a, e, or. All right. In this case now, we can just simply check if ch in vowels, and we do what we want to do. Sorry, we can check if ch in vowels, if ch in vowels, this will be much simpler. So I'm going to copy this. So if ch in vowel, we just check if the character is within our vowel list, we know it's a vowel. So instead of writing all that comparison, we can simply do this and some text, for example, and we still have the same stuff. So that one was an overkill. So I think that's the end of it for our video, this video on for loops. As I said earlier, a for loop is good for definite loops, while a while loop is good for indefinite loops. And a for loop makes your loops, your iteration, very simple. For example, you see this situation in this case where we use the ch in vowels. If it was a while loop, we have to have you'll be you have some extra lines of code. But with a for loop, it makes programming very easy and it makes things really fast. All right, so see you in the next video where we're going to be looking at nested loops. So have a nice time. Thank you.